Good afternoon, sir.
Welcome to my physics videos. As usual, we are talking about physics practical made easy today. And we are going to make a revision of some of the classical questions in physics. As you can see here, we have some of them here, which we're going to start with number one. Number one says, which one of the equation for a graph with a positive slope and a negative intercept? We have A and B here. If you have a positive slope and a negative intercept, why can't you draw your what? Graph sheet. This is your y-axis, this is your x-axis, x negative and y negative. For the slope to be positive, the graph must be rising. And for the intercept to be negative, it must cut across the y-intercept at the lower side. So therefore, your sketch will be like this, like this. This is a positive slope, this is a negative intercept. And you have an equation of y is equal to mx minus c. So this one, B, is the answer for a positive slope and a negative intercept. Likewise, you can be given the same question that asks you to find a graph with a positive slope and also a positive intercept. C. For a positive slope and a positive intercept, if you have a graph like this, it's your y, x negative, x positive, and y negative. The slope is positive, intercept is positive, so this is going to be like this. And the equation is going to be y is equal to mx plus c. Likewise again, you can be given a question that will be asking you to have a negative slope with a negative intercept. For the slope to be negative, m must be what? Minus. So now, if you have a graph like this, negative slope to fall like this. So that this m here is negative. So the equation will be y minus mx plus c. This is a negative slope, positive intercept. Another one that has negative slope, negative intercept is going to be like this. So we're going to fall like this. The slope here is negative, the intercept here is negative. So the equation is going to be y is equal to minus mx minus c. So these are the questions you see when it comes to sketching graph. So let's go to the second question. The second question says, in a linear graph equation, what does m and c stands for? The equation for a linear graph says y is equal to mx plus c. M stands for slope and c stands for intercept, where x and y are your variables. Let's go to the next question. What is abscissa and which one is ordinate? This is talking about your graphical axis. If you have a graph that has the y and x-axis is also known as abscissa, while y-axis is called ordinate. So these are the common confusions that students experience if they don't know these things. Next thing, what is the formula for calculating error in slope? If you have your slope like this, m, this is your y and x axis, error in slope, E of r is equal to 4w over nr. W is nothing but vertical scatter, because they can ask you what is the meaning of w in this error. N are the number of points you are plotting on this graph, while r is the range. That is the highest number at the x-axis minus the lowest number at the x-axis. So this is the formula for calculating error in slope. Next, we are going into what is known as instruments for measuring in practicals. So we'll review instruments for measuring in practicals now. Instruments for measuring current and voltage in the laboratory. Current, we use what is known as ammeter in measuring current. While in measuring voltage, potential difference, we use the voltmeter. Let's go into error analysis in physics laboratory. There are two classical main errors in physics laboratory: systematic error and random error. These are the questions that you are always acquainted with in exams, that are classical questions. What is systematic error? Systematic error is nothing but error due to the system, that is the apparatus. How can you correct it? It can be corrected by replacing those apparatus, because when an apparatus is damaged, you cannot use it continuously. It will give you an error. So you have to replace it with new ones. That is it. How does it manifest itself? It manifests itself by having similar measurements throughout your practicals. Example, if you have a wooden meter rule that you keep outside and rain beats on it, it bends, it shrinks, and it will always give you a value less than that meter rule. What are random errors? Random errors are errors due to human mistakes or human negligence. When somebody is counting the oscilloscope, oscillations, or when something is counting oscillation of a pendulum, and mistakenly you overcounted with 1 or you undercounted with 1, these are known as random errors. So how do you avoid them or minimize them? We minimize random errors by taking measurements of 2 or 3 variables and take their average. If you have measurements like x1, which is 0.1 and 0.2, so x mean is equal to 0.1 plus 0.2 all over 2, 0.3 over 2, which is 0.15. So this is how to minimize random errors, isn't it? So now we are talking about fractional errors. Fractional errors can be given in this form, and it manifests itself when we want to calculate it in percentages or fractions. If you have a measurement that says 4 plus or minus 0.02, that means maybe this is a reading that was taken from maybe a diameter or measurement of any matter in the laboratory. Fractional error is nothing but what? As 0.04, sorry, it's 4. 0.02 all over 4. This gives us 0.01 all over 2. So this is a fractional error. This is how to express it. In another instance, if they are giving you is equal to XA, YB, and ZC, what is the error in U? It's simple. Error in U, E of U, we find it by this error in A, X, this A falls here, all over X, plus error in Y, EY, all over Y, plus error in Z, C, error in Z, all over C. So this is how to compute the error in U.
But the other one is A all over A of error in A X all over X plus B Y all over Y plus C Y that one all over C.
Okay, sorry, this one is Z.
Okay.
Yeah. Thank you for the correction. That one is Z. So these are the basic error analysis that you find in the laboratories. So now let's go into electrical aspect of physics laboratory. In these physics practicals, you should know what are the electrical features such as EMF, because they can ask you define EMF. You can see what is an EMF. EMF and potential difference are just two things that people do interchange. EMF and potential difference. Electromotive force is the work done in moving one quantity of charge from one point to another without accelerating it. Or you can define it as the work done in moving a charge in a circuit when the circuit is closed, when the circuit is open. That means the circuit is not delivering current to an external circuit. While potential difference is the work done in moving charge around a circuit when the circuit is closed. That means the circuit is functioning. Another thing you have to know is that why is EMF always greater than potential difference? EMF is always greater than potential difference because when you buy a cell, a battery, you see it is written as 1.5 volt as the EMF. This is the EMF, but if it starts delivering current to an external circuit, this 1.5 is going to drop and it's going to the wires and heating of the apparatus, so it cannot continue with 1.7. It must drop to what? Less than 1.5. It must be less than 1.5. So that is why you have to know what these things are. The next thing we have to go into is there are a few calculations that you'll be given under this situation. For example, if a cell of EMF